Now let us generate ramp waveform. As we have seen square wave and triangular wave, very small code, simple logic. So already I've just typed it because it is just a very small one. So need not have to waste time in that. org0, first of all we want to just send from 0 to say for example ff or 255 decimally. So that much portion we want, and then it should come back to 0 and again next. So that is a rising ramp kind of activity we want to perform. So for that purpose I have just started with accumulator contents first of all cleared, that is accumulator make 0 0. So clear A, then a loop which we want to continue. How many times? That is whatever is your upper level as far as ramp is considered. Say for example at present I am taking it as ff or 255. So that is move a p1 comma a. So means accumulator contents are copied into p1. Port 1 just we are using. Then increment a, accumulator will get incremented by 1. And how many times the same thing is to be repeated, that is increment accumulator unless it reaches to value 255. So here we are using instruction CJNE, that is compare jump if not equal to what accumulator contents with what comparison immediate number, that is 255. What you have to do, repeat the loop. So unless it reaches to ff, it will go on repeating the same thing, and every time that whatever contents are there in accumulator, they are forwarded, they are copied to port 1. So gradually there will be rise in the signal, and whatever is this thing is repeated. So because we want to continue in the loop, so sjump start 1. So once again it will start newly. One cycle is generated, then again generated, then again generated. If you want this, like here it is in gap, then in between you can add delay. So we don't want here gap. So continuously it should rise, come down, again it should continue. Now delay, actual delay we don't want here, but just for the sake, if suppose you want to insert somewhere delay, then you can add it. So for that purpose I have just written that delay loop also in the program. So in between you can have a small delay, that is so that it will get a time. So R7 250 counter decrement JNZ DJNZ 250 times. At actual I have not used in this program. This is a very simple illustration. If you want in between, then one complete ramp is over one particular portion, then there will be delay, and then the second one, then third one. So like that also you can continue with. So that means this loop, in between this loop also here you can call delay. So one cycle will get completed, then it will skip some time, and then it will I'll call delay if we add here. So that effect also you can add. I will show you just without delay. First of all we will execute this, and then in between we will add delay. So this is save and rebuild, debug, start debugging. Okay, here you can see already I have taken this port 1 as a setup port. See here, this is your RAM. Stop here and you can see I have not called any delay in between. Getting? So this is a simple straightforward RAM. Now what we will do, we will add that delay. Just I will stop debugging here. In between I will call delay. After one set is complete, that is it reaches to 255 times, then I will call delay. You see the effect, what it happens. What will happen, we will see here. Suppose in between we add delay, then I will execute this. Directly it will not reflect. See here, this continue, but if suppose we make it in between, make it comment. Save. I will show you what exactly is happening due to delay. Now once again we will debug this. In between I have inserted. So okay, and now run. See here. So this way it will reach, and now see the waveform how it is happening. So it will reach there, then it will stay, then it will come down, and again it will continue. Getting? So this is one more observation you can have. Just by changing placement of delay, this kind of a sort of a trapezoid type of a thing, half, so that we have generated. Now what I will do, just a moment, we'll stop this, and this delay will add. This will, I will make it a comment. So this is our start one. Here I will make delay, right? So save and execute. And now debug. Okay, run this. It's coming immediately down. So there is no change in that effect. Here you can see. So if you want to make it happen somewhere else, so stop it. Once again we'll make this as comment, and here I will call delay. Save, debug. Okay, run. That is removed. In a fraction of second, just we are getting that ramp. This one. Remove this. What I want is just stop this. I'm showing you effect of delay, how exactly it works. This one I will now remove. See, So there will be in the beginning delay, but it is not directly reflecting in the final waveform. If we make it this way, then in the beginning it will show you the delay. So that also you can insert. So these are some of the forms how you can insert delay in between. Using this concept, we will produce staircase waveform. So first of all, let me remove all these, whatever we have unnecessarily added. Even one more thing here, instead of making it here, just see, if we make it here, one more effect you can observe. So save and stop this. Whatever changes we made, again rebuild and debug. Fine. See here, that will get delayed. What we are changing is the rate of that particular ramp we are changing. You can observe that effect. If we are keeping the same timeout, and you can observe. So these are some of the forms you can vary as per your requirement as far as ramp signal generation is considered. So I will remove all these unnecessarily delay statements. We don't want anywhere. Even there is no need to keep here delay routine, just for the sake. Sometimes if you wish that you want to change something, then that delay can help you so as to make it available if needed. For that purpose only I am keeping that delay there, nothing else, no other reason. So let it be as a part of our program. And if you want this particular, one more addition we can do. This is also one more form. Just see what is the effect. First of all, stop this, then save, then debug. Sorry, first of all let us save, then debug, and now build and debug. So, okay, let us have. So you can see the effect. In kind of a trapezoid, but the change, there is a change in the rate. So in the beginning part only you have observed how the waveform got changed. So just stop it. There is no need to insert in between delay. Fine. So this let it be. We'll go for one more. So I will make it new project. We want to produce ramp. We have produced ramp. Now we want to produce staircase. Same logic, just instead of changing in that, write a small code, one more code. I wanted to show you the effect of delay in the logic analyzer window, how it is affecting the occurrence of that waveform. For that purpose I have just shown you various say positions of delay statement, and it's ultimately the effect. Now what we will do is a simple staircase we will produce. So first of all quickly I will do. So this is staircase, enter. This is our only. Now here is a very prominent role of delay. You can see this is our 0h. We'll start. Move. Say P2, port 2 we will use, port 2 comma 00, from 00 we will start. Every time we will insert delay. So small call, just absolute call, delay, and move port 2 comma, say we will make it 3f, steps we want, enter, a call, delay, move, P2 comma hash 7f, 7fh, again a call, delay, move, P2 comma hash ff, a call, delay. Fine. So this many times we have done, and s jump, start. Okay, and here I will write small routine delay. So actually in such very small programs there is no significant difference, or not going to get affected that much, where we are writing very small say loop. Just 250 kind of a conventional counter I am putting. I'm basically telling you the logic. As per your requirement, you can change that delay counter, and you can go for absolute delay or long call. Long call means a call or L call. So that is as per your requirement, which we can afford. So if you have that much space, then you can go for L call. Otherwise, you go for absolute call. Simple. End. Right? Well, first of all, save this. Give name. Staircase 1.asm. Save. Then from this, let us add that file. Add file. Staircase.asm. Add it. Now close this window. Go here. This one. Build. Not created. So somewhere there is error. This one. Here you have to, since it is hexadecimal, you have to attach this 0. Save. Once again rebuild. So fine. Now debug. Start. OK. And go for execution. Let us open this logic analyzer window. We want port 2 we have used. So I will in the setup I will insert port 2. Okay, enter, and now close this window and execute. Getting a nice waveform of staircase. Let's see here. So if you want to increase or decrease the steps, that also you can do. I will add one more statement here. So let us stop debug and stop it. Here we will add before 0ff. Once again I will make it move. So P2, comma 0f. No, something in between. Make it F0. Okay. Hash 0F0 H, and then again delay. Now save, rebuild, again start debug. Okay, let us execute it. So that much, actually it is very close. Somewhere here we should have done. So that is not that much close. The look is not that much good. Let me change some value. Stop. Don't want this F0. It's very close. So somewhere F, make it 0f is very close. AF, that is also very close. I think we should give up. No need. It will not going to get, we are not going to get anything very significant out of this. So let us forget. By doing some small calculation also you can decide which steps you want, and accordingly you can proceed. Fine. So this is our, basically I have taken here 003E 3-4 level 00, 3F, 7F and FF. So these many levels I have taken. So in between also you can have one more step, and then you can proceed. So I can make it here simple. Move P2, comma AF 0AFH, and again a call delay. Yes, enough. Now it is enough. Debug, stop, save, rebuild, and now go for debug. Start. Okay, and this is run. Okay, now this is looking good staircase platform. So this I wanted, so that's why I spent this much time, 5-10 minutes unnecessarily. Okay, thank you.